Hi everyone. In this video we will remain in the descriptive statistics section of the course and focus on quantitative data. We're going to inspect measures of dispersion. Now, measures of dispersion, what are they exactly? Well, there are many different types of measures of dispersion. There's the range, first of all, which is the distance that separates the minimum and maximum values. So the range is simply the difference between the position of the max relative to the mean. The interquartile range is a measure of dispersion. It calculates the distance that separates the first and the third quartiles. So it's the distance between Q3 and Q1, which you would have seen in the measures of position video. Then there's standard deviation. Standard deviation measures the dispersion of the values by comparing them to the mean. The formula for the standard deviation differs slightly depending on whether you're using data from a population or just from a sample. If you have listed data, so individual access to the data that is obtained from an entire population, then sigma, which is the symbol for standard deviation obtained from populational data, is the root of 1 over capital N, where are added all of the differences between the individual data and mu, the average, and squared. The squaring is to avoid cancellations of positive and negative deviations. When sample data is concerned, you'll notice that the divider outside is not 1 over little n, but 1 over n minus 1. This will have to be explained later. The summation takes place between the observed values and x bar, which is the symbol used for the sample mean. And again, the deviation is squared, and then a root takes place on the answer. As we have seen in previous videos, notice how Greek letters are used in the first formula because it refers to population data, and in the second, Roman letters S and X bar are used. Now, the content of the roots are thought of or referred to as variance. So calculating variance is really just an intermediate step towards obtaining standard deviation. These calculations are done automatically by Excel when you have access to a data file. The standard deviation is an essential tool in statistics, and later on we'll see in inference as well. So within your Excel file, again, whether you have a French or an English version, you will find the function to find standard deviation. In French, écart-type Pearson for a population standard deviation, and écart-type standard for a sample standard deviation. In English, you would look for standard deviation standard or Pearson as well. What we will most frequently be doing is obtaining data from a frequency table and calculating standard deviations from that table. So if we have group data, we're going to have to remember to take into account the repetitions that take place on the observed values xi. In other words, we're going to have to think of how ni has an effect on our computations. So the formula is slightly changed because this time ni will keep track of how often the observed data has been repeated. Same goes for sample data, where you see the effect of the ni in the summation, which takes into account the weight of the different observations. If the data is presented in a frequency table and data is grouped, then we also have to remember to use the center of each group to replace the unknown values of x. So the formula is exactly the same as we saw in the previous slide, but with CI, the center of groups, representing or replacing the xi. And same goes for standard deviation from a sample. Now, roughly speaking, and this could be very rough at times, 70% of the observations are found within one standard deviation of the mean. So here I've used symbolism for population data, but it could be just as useful in a sample data setting. So notice I've moved one standard deviation left and right of the mean. So this interval contains roughly 70% of the observations. Two standard deviation displacements left and right includes roughly 90% of the observations. And by the time you've moved three standard deviations, roughly 99% of the data should be located within this interval. So this is a rule of thumb and nothing more.